Uh, Hello everyone. Now we are going to do one more experiment in fluid mechanics and machinery lab. Okay, in the first experiment we did on the flow measuring devices. The second experiment is the determination of coefficient of friction of a flow in a pipe. Determination of coefficient of friction of a flow in a pipe. That is nothing but we are going to do the experiment on major losses and minor losses. First we will do the experiment on major losses, later we will do on the minor losses. This experiment is based on the major losses. Now come to some theoretical background about this experiment. See, in the losses are losses in a flow through a pipe is mainly due to the is mainly classified into two categories. One is the major losses and minor losses. See, now we are going to do the experiment on this one. Later we'll do the experiment on this one, minor losses. See, the major losses is caused due to mainly due to the loss due to the loss of head due to the pipe friction, and viscous effect of the flowing liquid. Viscous effect of the flowing liquid. One is due to the loss of head due to pipe friction. Is due to the pipe friction. Another is the viscosity. Okay, this is the main reason for the main reason in the major losses. See, if you take any surfaces, any smooth surfaces, if you magnified this much of area, means if you zoomed by using microscope or some electronic microscope, if you view this very small area, you won't get any even surfaces. You will get some like that, some uneven surfaces. So when the fluid is moving over these uneven surfaces, that causes the friction. That is due to the one is the pipe friction, another is viscosity. We know it. That is the resistance to flow. All liquid is having own it or is having own resistance. All liquid is having its own resistance. Whether you take water, you take kerosene, diesel, any oils it's having its own viscosity. Okay, so in major losses there are two reasons caused due to losses, major losses. One is due to the pipe friction, another is due to the viscosity of a given fluid. Now the same thing here you can see with clear sketch. This is the one small magnified zoomed area of the any flowing surfaces. Here you can see these uneven surfaces, the crust and troughs, the valleys and hills. These are the hills and these are the valleys. Because of this uneven surfaces, if the surface is more uneven surface, like that the friction is the more. If the surface is somewhat less uneven surfaces, the friction will be the less. But if you take any smooth surface, if you take even the glass surface is also is having some roughness will be there, some surface roughness will be there. There is no any surfaces you will get the complete the uniform surface, like the complete uniform surface like a straight surface you won't get anywhere. Okay, and also just now you learned that major losses is due to the pipe friction and as well as the viscosity of the given fluid, viscosity of the itself only. The effects of friction with the walls, pipe walls and layers of molecules, which are the fluid very near to the pipe surface that experience a more friction compared to the above layers. You can see that layer almost stationary, next is moving slowly, and stationary significantly slowed. Okay, likewise the velocity of the fluid will also be changes. One we learned that the major losses is due to the friction, another is due to the viscosity, the very important term, viscosity. Now we will go back to the demo of an experiment. Now I will going to play the video. See, this is the experiment on friction. We are going to measuring that one. The first we are going to do by step by step. Here, here there are totally five pipes will be there. Five pipes. This one, second, third, fourth, and fifth. Okay. See these three pipes is having a same material, but different in diameter. Different in dia, different in diameter. This is stainless steel, this is brass, and these three pipes are GI pipes. Okay, this is brass, this is stainless steel. These three are the GI pipe, but but these three pipes are different in diameters. Means this is the 1 inch, half inch, and 1/4 inch, and these three are the same diameter, 1 inch. Totally five pipes are there. In that one, you are going to do the experiment. Three pipes are related to the different materials. Means these three materials are the different materials, and these three are the different in diameter. Okay, these are the walls for each pipes for each different experiments. See here you can see that this is a very small in diameter. This is 1/4 inch, 1/2 inch. This is the 1 inch. 1 inch, half inch, quarter inch, and remaining three are the half inch. This one, and this one. Here you can see this is the stainless steel. This one is the brass GI pipe, different in diameters. Last three are different in diameters. First three are same diameters. This is the main wall from the sump. This one is the sump. This is the main wall circulated to the each pipes, and this is the sump. This one is the sump. This one is the sump, storage tank. Sorry, sump. Here, this one is the YouTube manometer, same as in the last experiment. YouTube manometer. See, this is the specifications. In each experiment, you are having the specification. In all the experiment setup, you have the specification. The first, for the observations, you come and take the values, readings of this one. Here you can see that there are three different pipes. One is a stainless steel, brass, and GI pipe. All are 1 inch pipes, and the remaining three are the same pipe, but different in the this one. Actually, I made that one 1 inch, 3/4, and half inch, not quarter inch. 3/4 inch and half inch. Sorry. See, this is the stainless, and next one is the brass. This is 1 inch, 1 inch pipe, 3/4 inch, second pipe. Last one is the half inch pipe, half inch pipe. Totally five different pipes are there. Three are different materials and three are different diameters. And this is the storage tank we are going to call. And here you can see this is the butterfly valve. And also we're going to call it the measuring tank because here the scale is present is there. So that one you're going to call it the measuring tank. And this is the butterfly wall. Suppose the wall is in this position, the wall is in this position, that is the closed. If the wall is in this position, the wall butterfly wall is open. What is the water stored here that will be come out from the storage tank to the means measure tank to the sump. If it is like that, that is closed. So the water will be stored here, stored here. Okay. Next we will go. Here you can see that this is a closed position and now it is opened. Here you can see that I will show how the butterfly valve will operates. Here you can see this is the butterfly valve. This is the open position. Whatever the water is stored, that is will be come out from the measuring tank. Here you can see the opening and closing of the butterfly valve. The below one is the sump. And this is the YouTube manometer valves. This is to be set only in the ones and the experiment I already mentioned. What are the air is stored in the YouTube manometer. Only once you have to remove all those bubbles, the air molecules or water bubbles is stored. Only you have to do once in the experiment. Always it is in the closed position. And these are the pressure tappings. Which experiment on the pipe you are doing for particular that experiment, this pressure tapping should be opened. Remaining all are should be closed. Remaining all are should be closed. Here see once again I am opening the pressure tappings of one experiment, means the stainless steel experiment. Remaining all four different pipes, the pressuring tapping valves should be closed. See this one is I'm going to open, and remaining all four pipes pressure tapping valves should be closed. Now you will conduct the experiment. At the same time you should on this also, open that also. Okay, this is the demo of the experiment. We will conduct one trial reading here. See, now we are going to on the mains. Later, which experiment you are doing for particular that experiment you are opening the valve. Yes. Later, we onning the motor, switch on the motor, green color button. Later, set the flow. We have to do the experiment three different flow rates. At any three different flow rates, see, then the water is coming. Later, you can increase the flow rate or you can decrease the flow rate, but you have to take three different flow rates. Now we are opening the pressure tappings of particular the first pipe, that is stainless pipe. Remaining all valves are closed here. Right side pressure tapping is open. Next to the left side pressure tapping is going to be opened right now. Remaining all four experiment tappings should be closed. Now only once we have to do this one to remove what is the air bubbles is stored in the YouTube. Leave 10 or 20 seconds. After that you should close that, then only you'll get the reading. Here you can see some the difference will be there, some pressure difference will be there. That pressure difference should be noted down. That is the mercury level H in centimeter. You should take the values in centimeter. I note down the values and return to the tableau. See, for a pipe, I written that value. I note on other specifications. That is, we are doing 1 inch stainless steel, 1 inch stainless steel. Array, what is that? 0.02 to 28. You should we know that one. We cannot do the calculations on an inch and all those things. We have to convert into a meter in SI units. The total length is 1.5 meter. Three different readings. What is the H is came? You just note on it. Okay, that should be converted into a meter. The equation is there. Follow that one. Now we are going to collecting the one is YouTube manometer, another is the measuring tank. That's all. See here the water is rising up. We will take see now the water is rising. We will note down know that for 10 centimeter height how much time is taken. For 10 centimeter height of water rising in the measuring tank or a collecting tank, note down the time taken. Here the stopwatch. We when it is come to the 20, we note down that one. And I note down the value also. That is the thing that is taken. Now, so, okay, note down the value. So the calculations, all the things are there. Uh, H is the this is the H of water. H is equal to 10 centimeter. T is the time taken. You find the actual Q actual. A is the area of the collecting tank, and H is the height, 10 centimeter height. T is the time taken for to rise of water. Okay, this is the end of the experiment. The students should watch this video, and I am sending the values, observations, and tableau columns using that things to the calculations. Thank you.